Okay, so we're going to be trying to find the volume, and on all of these we're just going to set them up today because I think that's the really important part. I'm hoping that you can use your calculator and you can find it algebraically if you had to. What you would start with doing on all of these problems is trying to find what region that it tells you here. So we know that we have these equations, and so let's just go ahead and draw it. Don't worry about the fact of what it tells me here. We'll talk about that in a second. But let's go ahead and draw the picture. I will go ahead and put that in Desmos if Desmos is what you want to use. And one good thing about Desmos is I don't even have to solve for y, although I'll have to write the equation. But you can go ahead and graph it like that. X equals 0, and then also y equals 0 was our boundaries. And so when I look at this, it looks like it's this triangle right here, and that's sort of like the base of what we're looking at. Okay, and let's go ahead and find out where these cross. That's at 6 and 3, and we'll need that as we work throughout. Okay, some important things to think about whenever you're looking at a problem like these is what it tells you. It says cross sections are perpendicular to the x-axis. When the cross sections are perpendicular to the x-axis, you're going to use x values. If it says perpendicular to the y-axis, we use y values, and I'll show you some of those as we go along. So what's going to happen is we're going to make some squares for A that are perpendicular to the x-axis. So one side of the square is perpendicular to the x-axis. Well, the rest of the square, it's 3D, so it's coming up. Like there's a square coming up here, and there's another square here coming up here. So it's kind of like there's a square right there coming up. And then there's another one kind of over here. There's a square all the way throughout, and what we're doing is we're adding all those squares together to find the volume of that picture. Okay? So what you're going to do when you find the volume of these is you're going to do the formula, the basic formula, is the integral of the area of the cross section. That's the basic idea. So if you know the area of that picture, then you're just going to do the integral, and that's going to add all of those areas together. So in this problem, because we're doing perpendicular to x-axis, we're going to use an x's, so it's 0 to 6. And I know that the area of a square is side squared. So what I need to figure out is what the length of the side is, because if I know the length of the side, that tells me how to find that volume. The length of the side is just this right here, which is kind of a radius that we've been looking at when we find volumes and areas. That's just the function that's 0. So all I need to do is come over here and solve for y, because I know I need to be in x's. So I'm going to subtract y and divide by 2. And so one side is that, and so the area would be that side squared. And we're going to use that as we go to the semicircles and the circles and the equilateral triangles. We're going to use the fact that that's the length of the side. Okay? And that's all. So if you find the area of whatever the cross section is, it just goes into the integral, and then the integral from wherever to wherever, depending on which way you're solving it. So look at B. So this time it's the same picture, but instead of squares, we're drawing semicircles. So that would be the diameter, and you have this little circle coming up here. Or here's a diameter, and you have this little circle coming up. And you're just adding all those little semicircles together. Okay? So because all of these are perpendicular to the x-axis, it's still from 0 to 6. And then we're going to figure out what the area of a semicircle is. Well, I know that a circle is pi r squared. So a semicircle is half of that. Well, I'm going to put the pi over 2 on the outside, and I'm just going to put my r squared right here. Now, what I know from A is that I know the length of this side is just that right there. But that's not the radius of the circle. That's the diameter. So what I have to do is kind of ugly, but it's sine of 6 minus x over 2. That's the diameter, but then I divide that by 2. So again, that's kind of ugly looking, but that would be the volume of that one. And that's because this is pi r squared and then divided by 2. That divided by 2 can be in here. I just knew that it would kind of not look as pretty, so that's why I wanted it to be on the outside. Now, circles is the next one. And as far as circles goes, it's the same exact thing as semicircles, except it's not pi over 2. It's just pi. And that's because, and I'm not going to draw this one because it's harder to draw, but that's just because you've got that part of it underneath. So you've got like a semicircle on top and on the bottom. And so the volume there is basically the same thing without the 2 on the outside. It's still dividing by 2 there because it's still pi r squared. And r would be the side divided by 2. Alright, equilateral triangles. That one is a little bit tricky. And I can show you where the formula comes from if you're interested. And it has to do with 30, 60, 90 triangles. But what we can figure out about equilateral triangles is that the area of an equilateral triangle is square root of 3 over 4 times one of the sides squared. I'm calling it the base. You can call it the side, whatever you want to do. It makes sense that it's a fraction of b squared, because b squared is kind of like, that would be a square. And so it's a fraction of it. And if you're interested, let me know later and we'll talk about it. But it's coming from a 30, 60, 90 triangle and trying to find the lengths of those sides and the fact that the sides are the same. So that's the formula when you do equilateral triangles. So what you do, and basically it's the same picture except there's just triangles coming up. So it's 0 to 6 still, no pi. Started to put one, but there's no pi because this isn't talking about circles. Square root of 3 over 4, and then whatever the length of the side is, which we already know from A, and then squared. Okay, on the right triangle one, again, same kind of idea, and I can draw it for you if it helps. But what it means whenever it talks about it is that there's a right triangle, and this is one side of it. Base is in the coordinate plane. That just means that's one side of it. And so I don't know if it's coming up this way and coming down or this way. It doesn't really matter. But if it was coming up that way and coming down, it's telling me that the height is 5. And I just need to figure out what that base is. So the formula would be 1/2 base times height. So 1/2, whatever the base is, times the height, which they tell me is 5. So when they tell you the height of something, they're telling you one side of it. So the base is just this same side that we've been looking at on all those other problems. So this is just 6 minus x over 2. Okay. We're going to do basically the same kind of problem. This one's just a tad bit different because the base is a circle, and it seems a little bit different as you start manipulating the problem and as you start working it out. So on A, well, let's start with the problem. It tells me that we have x squared plus y squared equals 4 is our bound. Now you can graph that in Desmos if you want to, but what happens is that it's a circle, and the radius is 2. You just take the square root of the 4, and that tells you what the radius is. So that's what your equation is going to look like. And it is still like the negative 2 to 2 would be there as well. So in this problem, it says we're doing squares. Again, perpendicular to the x-axis, so that's nice. All right, so squares. So we're going perpendicular to the x-axis to make one side of the square. And if you want to make the other side, so you can just think about what it looks like, there's one of the squares. and I'm finding the area of each of those squares. I'm taking the integral and adding it up. So I'm going the integral from -2 to 2 of whatever the side is squared, since it is a square. Okay, the square, or this side, to figure out what the two parts are, if you solve for y here, you would get, subtract your x squared and take the square root. You get plus or minus 4 minus x squared. That's important because that tells you what the two equations are. Like this top part of the equation is the square root of 4 minus x squared. The bottom equation is the negative square root of 4 minus x squared. And that's important because that helps me figure out what the length of that side is when I do the this part right here, because I need to know the length of that side. I need to know that whole side. And by finding these, that tells me how to find it. So there's a couple ways that I can put what goes in here. This part right here is square root of 4 minus x squared. This part right here is negative square root of 4 minus x squared. One way I could say the length of that side is to say square root 4 minus x squared minus negative square root 4 minus x squared, which is really long. That would be the whole side. Another way to do it is to say, well, if this part is square root of 4 minus x squared, if I multiply it by 2, that would give me the length of that whole side. That's the way I prefer to write it, just because it's simpler. It's less stuff. But you can write square root 4 minus x squared minus negative square root 4 minus x squared as the length of the side as well. That is the same if that one makes more sense to you. I just like to simplify it so I don't have to write it that way. So now when I do the semicircles on the same picture, it's still -2 to 2. I know there's going to be a pi over 2 and then a r squared. Well, this is the length of the whole side. So if I'm trying to find r, I'm going to divide that by 2. So I'm just going to get square root of 4 minus x squared, because that's the length of half of the side of the semicircle if that was a semicircle instead of a square. Again, circles is very similar to semicircles without the 2. So pi integral -2 to 2 square root 4 minus x squared squared, and then there's that one. Equilateral triangles. Alright, I already know from my formula above that that's going to be square root of 3 over 4 times the base squared. The base is the same as the base for the square, so that's just 2 square root 4 minus x squared. And then just to be tricky, here's one with a rectangle of height of 2. Still pi, -2 to 2. We know that rectangles are length times width, or length times height, or however you want to say it. So it's going to be one side times its height. Its height is 2, so I know that that part's 2. The length of the side is the same as the length of the side that we were working on whenever we found the squares in A. So that is still 2 square root 4 minus x squared. Alright, so first of all on this one I want to go ahead and find the region that is the base. And so x plus y equals 4. If you want to solve that for y, it's 4 minus x. So I know it's going to look something like that. X equals 0, y equals 0. So this part right here is the part of the base that we're looking for. And these intersections are both 4. And so we're doing squares and semicircles and circles. So this is the length of the side for the square or the semicircle or the circle. It's all the same. If I draw a circle, it comes up, but if it would have been a semicircle, similar picture, just rounded instead of squared. So we're still going perpendicular to the x-axis, so this is the integral from 0 to 4. And then we just need the length of that side, which is just 4 minus x because that goes to 0. So 4 minus x squared because it's side squared for the area. For semicircles, pi over 2 because I only want half of pi r squared. This is going to be r. The length of that side that we just figured out, 4 minus x, is the whole side. So we have to divide it by 2 to get the radius. So this is 4 minus x over 2, and then squared for the radius. And then circles, same thing without the pi over 2. It's still a pi because it's pi, and then r squared. Alright, so let's talk about what happens when it's perpendicular to the y-axis. Okay, so let's draw a region first. So we have y equals x squared, and y equals 4. This would intersect at negative 2 and 2 if I need that, and that's at 4. So it's that region there. And this time it says it's perpendicular to the y-axis. When it's perpendicular to the y-axis, that means that the base of whatever I'm looking at is going this way. I'm trying to make semicircles here. So my semicircles are still coming up. That's just like the diameter of it. So my semicircles kind of looks like that right there. And then they're coming up and down instead of going sideways. Because they're coming up and down, that means that they're going from here to here. So that's 0 to 4. So we have to use y values when it's perpendicular to the y. It's still a pi over 2 and then r squared. The question is what's r? So because you have to use y values, think about solving this for x. That means you would take the square root on both sides. So this side of the equation is square root of y, and this side of the equation is negative square root of y. So if I'm thinking about, like, from where to where, I'm going to subtract that minus that to get the whole side. I don't really want the whole side, though. I really only want half the side because I need the radius. And so half of the side is just one of those. So that's square root of y that goes inside of there. Alright, equilateral triangle. Same picture except instead of curvy it comes up in a triangle. But we already know that it's 0 to 4. We know there's a square root of 3 over 4 according to the formula we found. And then side squared. Alright, it's not just square root of y because that's the radius. It's 2 square root of y because it's the whole side. And you could write that as square root of y minus negative square root of y if you wanted to. Again, I just like to simplify it into 1. Alright, last one. And we're still going around the y-axis or perpendicular to the y-axis. So let's go ahead and draw our picture. There's y equals x equals 0 is here, and y equals 4. So it's this region right here. And our first thing is squares, so I'm going to draw a square first. So hard to draw those 3D because you got to think about the fact that they're sticking up. Alright, I know that it's going to go from 0 to 4 because I'm drawing squares all the way up. And I just need the length of a side squared. And it's in y's because it's perpendicular to y. So I just need the length of this side. This is on x equals y, and then that's just on 0. So we're using y, so that would just be a y. And then if I do semicircles, I know it's a pi over 2 on the outside, and whatever the radius is, and the radius is half of that y, so y over 2.